Okay, here we go. 5.10 notes. Solving radical equations. Write down the steps to solving. Okay, so 3 steps. Isolate the radical. Remember, the radical is anything that has this symbol in it. Step 2, raise both sides of the equation to the power of the root. Remember, the root is just whatever number is right here. Okay, and then number 3, simplify and solve. Check for extraneous solutions. Extraneous means that you get a solution, but it doesn't actually work. But I'll show you how to do that. So here we go. I have 3 examples to show you. We'll just go ahead and do this real quick. So we're going to solve, and we're going to check. So here, we're going to solve 6 times the square root of x plus 10 equals 42. We need to, step 1 says need to isolate the radical. So we need to get this radical by itself. So we need the 6 to go away. You think of this as 6 times the radical. So I'm going to divide both sides by 6. So that these cancel out. I'm left with the square root of x plus 10. 42 divided by 6 is 7. The next step said to raise both sides of the equation to the power of the roots. Now, this is a square root, which means that I'm going to have to raise both sides to the power of 2. And you'll do that just like this. Again, why does that work? Because you know by now that the power of 2 and the square root will undo each other. And this problem, that's going to leave us with what's on the inside of the square root, and that's x plus 10. Equals, and then 7 squared is 49. Then we will subtract 10. And x equals 49 minus 10 is 39. Let's just go ahead and check that. Make sure that it actually balances the equation here. So let's do the check step in purple here. So I have the 6, I have the square root of x plus 10, but x, I'm checking 39. So I'm going to do 39 plus 10 equals 42. 39 plus 10 on the inside is 49. 49, the square root of that is 7. So I make that replacement. 6 times 7 is 42. And there you go. You might see you might think there's no reason to check. It's a good habit to get into, especially when we get to example 3. You already want to be in that habit when you get to example 3. But because it works, we will circle this as our solution. If it hadn't worked, we would say there's no solution. So in example 2, I chose this one because it has a lot more to it. Remember, step 1 says to isolate the radical. So we need to get the cube root by itself. We need to therefore move the -2 and the -8. So the first thing I would do is, we're treating this like a variable, like the whole thing. So we're going to have to add 8 to both sides first, so that these can cancel. -12 plus 8 is -4. I'm going to bring down all this right here. Divide both sides by -2, because this is considered division. Multiplication. And the opposite of multiplication is division. These cancel. The cube root of 3x minus 4 equals, and then -4 divided by -2 is 2. Now that I've isolated the radical, I want to raise both sides to some power, and it's just whatever the root of this radical is. Now the root of this one is 3, so I'm going to raise both sides to the power of 3. Again, think about why you're doing this. You're trying to undo the cube root, so you have to cube both sides. That's why we're doing that. We have 3x minus 4 equals 2 to the power of 3. That's 2 times 2 times 2, which is 8. Add 4 to both sides. Add 3x equals 8 plus 4 is 12. Last step, easy, is divide by 3, and x equals 4. I'm not going to circle it yet, because what you do is then you go back and check it. Again, I'll do the check step in purple. I'm going to do it on this side this time. So I have -2. times the cube root of 3x minus 4, but for x I'm plugging in 4. So let's just go ahead and do that. Let's go ahead and simplify the inside of the radical first, because remember we have to follow our order of operations. So we treat this like almost like parentheses. So let's see if we can do this mentally. Order of operations, I should do 3 times 4 first. 3 times 4 is 12. 12 minus 4 is 8. Can we take the cube root of 8? You can do this on your calculator, or if you know that 8 is a perfect cube, and it is, the cube root of 8 becomes 2. Okay? Order of operations says I should multiply this before subtraction. So negative 2 times 2 is negative 4. I bring the minus 8 down, equals negative 12. Negative 4 minus 8, if you calculate that, is negative 12. And so it does indeed work. Again, you have to check that. And you'll see why, because we're about to do example 3, which is our last example. Then we'll be done with the whole unit, actually. This is our last example of Unit 5B. So, let's switch back to orange. Now this one is a little different. It's a little special because you have x inside a radical, you have x outside a radical. So you have it in 2 different spots. It doesn't change the steps that we saw earlier. It's just when we go to check, we're probably going to be checking 2 answers. Now this one, the radical is already isolated for us. So we're going to raise both sides to the radical's root. Remember, we assume there's a 2 there. So we're going to raise both sides to the power 2. So what happens is on this side, the power 2 and the square root, they undo each other. So I'm left with the inside, which is 2x plus 14. Over here. 1 second. Sorry, 1 second. Over here on the right side, I have x plus 3 to the power 2. So what does that mean I have to do? I need to multiply x plus 3 by x plus 3. FOIL, if you need to know. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. These are like terms, so this becomes x squared plus 6x plus 9. Alright, so this becomes that with the work I showed here. Look what we have here. Quadratic. So, because we're trying to solve this problem, I need to get this quadratic equal to 0 on one side. I'd rather keep x squared positive, and if I move this over here, it will become negative. So it would be easier for us, in the long run, to just move this over here. So let's go ahead and subtract 2x, because that'll make that cancel. And then where would I subtract 2x over here? I would do it right here, because like terms. Also, to make the 14 go away, I'm going to subtract 14. Where else would I subtract 14? Right here. So these can cancel. And so this adds up to 0 on this side. Bring down the x squared. Like terms here, 6x minus 2x is 4x. 9 minus 14 is negative 5. I think you should know what to do from here. I think you should bring the 0 down. We should factor this. Okay? So we have x and x. So 5 times 1, 5 times negative 1 is, wow, can't speak today. It's negative 5. And I chose 5 and negative 1 because 5 minus 1 is positive 4. Remember, what times what is negative 5? This combination. And what plus or minus what is 4? 5 minus 1 is 4. So positive 5, negative 1. And we know the trick is this gives us negative 5. This gives us positive 1. So this is what we have for our solution, but we need to check both of these. Now, since we're checking a couple numbers, we want to keep track. So let me show you how to check this real quick. We're checking two things. Remember, we're checking two different solutions. The first solution we'll check is x equals -5. So here's the check for this one. So I'm plugging into this right here. I have the square root of 2x plus 14, but x becomes -5. Sorry. The inside, if I do order of operations, 2 times -5 is -10. -10 plus 14 is 4. Again, if you're having trouble with that, you can plug it into your calculator or work it out slower. On this side, I have -5 plus 3. These are like terms. That's -2. I can do the square root of 4. The square root of 4 is 2. And so let's see what we have here. We have 2 equals -2. Is that true? No, that is not true. So we're going to reject this one. Let's go ahead and, here I'll do this in a different color. Let's go ahead and check x equals 1. Now if it works out for this one, x equals 1 is our solution. If we also have to reject this one, then there's no solution. So we'll either have this as our only solution or we'll have no solution. Let's go ahead and just plug it in. I have 2 times 1 plus 14. Again, I'm plugging 1 in for x right here. Equals x plus 3 becomes 1 plus 3. So on the inside, 2 times 1 is 2. Plus 14 is 16. So I have the square root of 16. On this side, I have 1 plus 3 is 4. The square root of 16 is 4. And so I have 4 equals 4. Is that true? Oh, all the time it is true. So this is good. And so our solution is x equals 1. Okay, great job. You guys have been doing great in this whole section. And I'm glad this is working out for you guys. Don't forget to like and subscribe, and I'll see you in class.